Hey everyone, and thank you for joining me. Today, we're going to be discussing both the basics of angles and triangles in the start of a series of videos about geometry. Here, we're going to cover topics such as what defines a triangle, the different types of triangles, the different types of angles, and towards the end, we're going to get into solving and classifying the different angles of a triangle. So, first of all, let's start with what defines a triangle. Well, for today, there are three main characteristics or traits that I will be using and that you should know to identify a triangle. First of all, a triangle has to be a closed shape. Now, what this means is that if you put your pen on a piece of paper and draw a triangle, you shouldn't have to lift your pen and you should end up right back where you started. So, the red triangle right here is a good example of that. As you can see, you have one, two, three different vertices. And if you were to draw this on a piece of paper, you would be able to draw it basically just three lines with a pen without lifting it up, and you get back to where you started. Now, the magenta one down here, on the other hand, is a little bit different because, well, you can draw it without lifting your pen off the paper. You don't go back to where you started, right? You end up at this area right here, which is not where you started. And because of that, it's open. Now, a triangle also has to have three sides. So you can see that this blue example right here, and the red one that I talked about earlier, both have three sides, which is wonderful. They're triangles. But the yellow square, on the other hand, obviously is not a triangle, because, well, it's a square. It has four sides. And finally, a triangle has three angles that all add up to 180 degrees. This is important for solving triangles, specifically with respect to their angles, and we'll come back to that concept later in this video. Right, now based on what we talked about, with a triangle being a three-sided, three-angled, closed shape, there are three different types of triangles that we come across. So the first one is an equilateral triangle, which is going to be when you have three equal sides. So side 1, side 2, and side 3 are all equal in length to one another, is what that means. Now, we'll come back to what that means for the angles of the triangle. An isosceles triangle consists of two equal sides. So you can see here that we have the lines going through, which means that they're equal to one another. And we have this third side down here, which is not equal to the others. And we'll also explore the angles of that triangle later. Now, finally, we have a scalene triangle down here, which is when there are no sides that are equal to one another. So side 1 over here is completely different from side 3 over here, which is completely different from side 2 down there. Alright, now continuing our discussion with triangles, you can see clearly here that there are three different types of angles that we're going to talk about today. Now, there are more than three types of angles generally, but we don't care about them for the purposes of the basics of triangles. So the first one is going to be the acute angle, represented up here. And what this is, it's an angle between 0 degrees and 90 degrees. So an example would be a 45-degree angle. The second type of angle that I want to cover is the right angle, which is exactly 90 degrees. So what this means is that these two lines are going to be perpendicular to one another. And finally, we have the obtuse angle, which is measured at between 90 and 180 degrees, and you can see it right down there. So with respect to solving the angles of our triangles, we're going to be first identifying what type of angle they are, and then going ahead and calculating what the missing angle is. So I'll go ahead and show you an example. Okay, so based off of the last few minutes of theory, we can start to get an idea of how to solve this problem. So we know that there are three different angles in a triangle that have to add up to 180 degrees. We also know that there are three different types of angles with respect to triangles. We have our acute angles, which are between 0 and 90 degrees, our right angle, which is exactly 90 degrees, and our obtuse angle, which is between 90 and 180 degrees. So now that we've gone through that quick recap, we can see that we have two angles written out here. We have angle A and angle B. So my question to you is, are angles A and B going to be acute, right, or obtuse? Well, the angles would both be acute, because 80 is between 0 and 90, and B is also between 0 and 90, right? B being 60 degrees. So that's pretty much all that there is for that definition there. Okay, so to start on the calculation itself, we're going to first off substitute A as being 80 degrees and B as being 60 degrees. So that's going to give me 180 degrees is equal to 80 degrees plus 60 degrees plus C. Now what we want to do is add 80 and 60, which is going to give me 140. So 180 degrees is 140 degrees plus C. Now to isolate from C, we have to subtract 140 from both sides. 140 degrees minus 140 degrees, which gives me 40 degrees as C as my final answer. Okay, so I would like to follow that up by going through this example right here. So as you can see, we have three angles again, which means as it's a closed shape, we are working with a triangle here. Always good to check. And D and E are both 70 degrees here. So it asks us, what is angle F? Well, here we're going to follow the exact same process as before, right? So we're going to say that D is equal to 70 degrees and E is 70 degrees as well. Well, that's going to give me 180 degrees is 70 degrees plus 70 degrees plus F. Or 180 degrees is 140 degrees plus F. Now we're going to subtract 140 from both sides to isolate for F, which is going to give me 40 degrees is equal to F. Okay, so now we're going to work through this example right here. So we're going to have triangle GHI here, and you can see that I is equal to 120 degrees, which is going to make it an obtuse angle, right? Because it's between 90 degrees and 180 degrees. Now, what's interesting about this problem is that we have G is equal to H, and it asks us to solve for what H is. Now, by solving for H, we also solve for G. It is something that I hope you can recognize here. So we're going to start with our substitutions. So we're going to have 120 degrees for I, and at this point, we can sub in either one. It doesn't really matter. I'm going to say that G is H here, but if you put H as G, it wouldn't make a difference. So we have 180 degrees is 120 degrees plus H plus H. Now, we can't add 120 degrees and H. We can only add a number and a number, or a letter and a letter. So that's exactly what we're going to do here. We're going to subtract 120 from both sides. And 180 minus 120 is going to give me 60 degrees, which is going to be equal to H plus H, which is 2H. Now, to isolate for H, we have to divide both sides by 2. Which is going to give me 30 degrees is equal to H. Now, remember that H is also equal to G. So we'll have 30 degrees is equal to G. And if you have any doubts about this, you can always check. It never hurts to check, just to plug in G is 30, H is 30, and I is 120 into your original formula to check that they add up to 180 degrees, which they do. Okay. So if you are interested, you can go ahead and pause the video to try this problem on your own and come back here when you're ready. All right, so what we're given here is J is 65 degrees, K is 55 degrees, and these are both going to be acute angles. So we did solve for angle L now. Well, this could be done by the formula 180 degrees is equal to J plus K plus L. And at this point, you probably have this formula memorized. So we can sub in 65 degrees as J and 55 degrees as K. That's going to give me 180 degrees is equal to 65 degrees plus 55 degrees plus L. Or 180 degrees is equal to 65 plus 55 gives me 120 degrees plus L. Now, subtracting 120 degrees from both sides, we get back that 60 degrees as L is our final answer here. And this is also going to be an acute angle. So this triangle is an instance of 3 acute angles. Alright, so just as the final example for angle calculations, I wanted to go through this instance right here. So we have n is 60 degrees, O is unknown, and it says that there's a third angle M. Well, I wanted to let you know that it's usually mathematical convention to write this square right here as being in place of 90 degrees. So what we get is that M is going to be 90 degrees, as is that angle right there, okay? So anytime you see this square between two lines that are perpendicular or look perpendicular, because sometimes they can be there to clarify that they are perpendicular, what you are working with is a 90-degree right angle. Okay, so in this case, we're going to substitute 90 degrees for M and 60 degrees for N. It's going to give me 180 degrees is 90 degrees plus 60 degrees plus O. Well, in this case, we're going to add 90 degrees and 60 degrees, which is going to give me 150 degrees plus O, subtract 150 from both sides, and 30 degrees as O is our answer. Now, this is a triangle that we are going to come back to in the future, the 30, 60, 90 triangle. But for the time being, it's pretty much just another calculation, so don't worry too much about it. Alright, now I wanted to end off the video with something that we discussed earlier, but never really came back to. And that's the idea of isosceles, scalene, and equilateral triangles. So how do we determine them in these contexts? Well, an equilateral triangle is going to have 3 equal sides. And those 3 equal sides are always going to have 3 equal angles. We didn't cover one of those today, but the JKL triangle was the closest one to that. So if J and K were both 60 degrees, L would have to be 60 degrees by association. Now, one way you can think of it is that the largest angle is always going to be opposite to the largest side. The same is true the other way around, right? The smallest angle will be opposite to the smallest side. And I think the clearest way to illustrate this is with triangle GHI right here. So I is going to be the largest angle in this triangle, and it's opposite to the largest side, right? It's adjacent to, or right beside, these two sides, which are going to be a lot shorter than the main side. So, with respect to what these triangles are, triangle A, B, and C is going to have 3 different angles. And if a triangle has 3 angles of different magnitude, or they're a different number, then we say that it is a scalene triangle. Basically, it has 3 sides of different lengths. JKL, which had 3 different angles, is also going to be a scalene triangle. Now, on the other hand, triangle DEF, which you might remember, D and E are equivalent angles, is going to be classified as isosceles, or something that has 2 sides that are the same and 1 side that's different. The same is going to be true of triangle GHI over here. Finally, we go to triangle MNO, which is on the far right. So this triangle is unique just because it has a right angle. And we call those right triangles. Right triangles can be either scalene or isosceles. So the difference just depends on whether these 2 sides are going to be the same or not. Here they are not the same, so we consider it to be a scalene triangle. All right, that's it for today. Thank you very much for your time, and I will see you in the next video.